Hey, this is Brad Peebler with the Foundry, once again coming at you from NAB 2016. We've just stepped out of the Lytro keynote, which was beyond standing room only, and we're lucky enough to pull John Carafin, head of light field video at Lytro, who gave a brilliant presentation. John, congratulations.
Hey, thank you so much. Really appreciate it. I didn't even realize how many people were there until I actually got up on stage because I was just so focused on what we were going to show and getting all the hardware and all the software ready. I've actually never seen a room that full at NAB, so it's just exciting to us just to get that kind of response.
Well, it was, I think, well-deserved, as I think a lot of people are very interested in light field technology and what that means for production and tools. Can you give us just a very brief introduction to light fields, and then we'll talk a little bit about the techniques that you showed?
Yeah, sure, absolutely. So a light field system, as we build it at Lytro, is taking the rays of light, and rather than converging them onto a sensor at one focal plane, we use microlenses to break apart all of those rays of light and capture the actual light field. So it's essentially a holographic imaging sensor.
And you showed some really cool techniques tonight using Nuke Studio and some technologies that you have added into Nuke to manipulate those. Can you tell us some of the advantages in the post-production workflow to working with light fields?
Well, from a software standpoint, it's great working within Nuke because every artist out there that is a compositor already knows how to use it, which is fantastic. And from an I/O and from an actual processing standpoint, it's really the ideal architecture to launch light field in. From a workflow standpoint, some of the features that we have and some of the things that we showed today include the ability to depth screen. So basically by using the volume, all of those rays of light, you're able to then extrapolate foreground and background objects. So you can essentially have no green screen but get the same effect as a virtual production with the green screen by having just the light field alone. We can do other things where obviously can change your focus position, we can change our depth of field. Any camera parameter is now a completely virtualized decision that you can then either use the on-set decision or change your mind to do something in post-production.
You talk about the depth screening, and am fortunate enough to have seen in advance some of those techniques when I came to visit you. Funny enough, today there was the shot where the couple was standing there and their daughter was in front of them, and you keyed out the background, and then you showed that you could also key out the daughter. It's obvious now. It hadn't occurred to me that of course with a depth screen you can key out, you basically create any window of depth you want to be in the final shot.
Right, and it's not even just limited to that window of depth. You're also doing light field segmentation. So let's say you have a tree that's at the exact same plane, you can remove that by virtue that it's not within the same object region. So it really is freeing in terms of what you're able to do just by virtue of capturing with the light field.
So now I'm going to play the hungry, feature-obsessed user and ask, so would it be possible now or some point in the future to actually have different depth masks or depth screens using rotomasks, so you could have certain things from this depth and certain things from that depth?
Yeah, absolutely. So there's actually a couple shots that were in the film where we had multiple refocus elements by using that screening technology so that you can implement different focus positions and have things that traditional optics can't actually achieve. So you can depth screen and recomposite anywhere in the scene.
And of course, when you capture these light fields, it's quite a bit of data, yeah?
A little bit of data, yeah.
A little bit of data, and as a result, there's so much flexibility, but does require some processing. You also showed the ability to remote process. Can you tell us a little bit about that? I know that we've been working together on some very exciting new technologies there.
Yeah, so Foundry has been amazing. You guys have some of the best software and the best applications in order to achieve the cloud compute environment. We're also working in collaboration with Google in order to enable that ecosystem. So the idea here is that right after capture, you can upload all of that raw light field content to the cloud, and what it enables you to do is have one centralized storage architecture that every artist globally or between multiple facilities can work within, so that way you don't have to shuffle the light field data back and forth. And the only thing that you're actually streaming down now is that UI, and that is hugely important as we move forward with any cloud architecture, that if you have to mirror the data, replicate the data, and work with multiple post-production facilities, it really starts to fall apart. So while we can have our plugins easily used on any local farm or local architecture, having the ability to remotely access and process gives you the capability of using just a low bandwidth signal and then a laptop or even your phone, and then do high-end visual effects compositing.
So another thing that you demonstrated, again, wasn't immediately obvious to me until you showed it, and then I thought, of course, was the ability to use the light field information for camera tracking and camera stabilization. So, you had a fairly chunky move on the camera, which was, as you pointed out, the result of dragging it across just an unfinished concrete floor. When you track that, is it actually then sort of blending between the different the subpixel capture of those of the light field?
So the tracking process keeps it from basically the center axis of the light field. And that's just a tracking process to understand how the camera physically is moving in real-world coordinates. When you perform optical stabilization, that's when you then resample from the optical system itself, and then you shift basically your UV coordinate, or what perspective of the actual lens that you're using, and that allows you to then stabilize or smooth that camera track without having any parallax incorrectly baked in if you're doing just a 2D tracking transform.
So you've got, as you mentioned, the ability to change your depth of field. You've got, and what you showed today was the optical depth of field, and then you've also got a computational depth of field where you demonstrated some really artistically beautiful uses of that. Can you describe a little bit of what people can expect from that?
Yeah, sure. So the current optical system provides the equivalent, based on like an Arri Alexa 35mm cinema system, of max aperture of around an f.9 lens. But because you understand where all of those pixels physically exist in space, you can then computationally create an even larger aperture. So we were showing at the session today that you were creating an f.5, an f.3, and f.2 aperture, which is giving you a depth of field that is so shallow that you physically, as a human operator, couldn't keep an object in focus that's actually moving in time. So that's some of the capabilities that you're able to achieve and perform almost this miniaturization of the world, because that's what a miniature scale object would actually do. So it's just really artistically interesting, and working with both David and Robert on this, they were able to explore how to tell the story using those creative options, and using Nuke Studio to do that in order to actually keep it in cut order, and then use Nuke to do all the processing.
There was another shot, and I know you didn't get to show all of the things you were hoping to, and I don't know if you were going to show this, and maybe I was imagining it anyway, but there was a shot where a soldier was shot and killed and fell to the ground, and it seemed to me there was an exaggerated motion blur.
Yes. Yeah, so what we're able to do through computation, because we understand how all the rays go through the lens, but we also understand how the rays travel over time. So it's something that we call volumetric flow. You can think of it like a fluid simulation, something like that. And with that very rich metadata, when you capture in this high bandwidth mode, what you can do is computationally change your frame rate, change your shutter angle, and then do things both for distribution, so you can re-release in multiple formats and multiple optimized aspects for whatever display type you have, or you can do things very creatively. So in that example, we're actually showing the equivalent of a 720-degree shutter angle, which is just silly, right? And it was giving this dreamlike effect, and we were ramping time from 24 to 120, and you're seeing things slow down and actually blur off of the screen. So it was enabling a different way to tell that moment and increase that anxiety, slow the motion down. It was just a really unique way that David and Robert were able to articulate that moment in time.
I have some friends in the CG world who have actually taken Moto, for example, and created their own sort of reverse engineered what a Lytro sensor might look like, and created some fake Lytro live images and posted them up on your website. You talked today about the integration of CG and how there will be sort of off-the-shelf rigs people can import into their 3D system. You also mentioned that means that you can create a 4D light field in CG and marry that to the captured footage. Tell us a little bit about what that encompasses.
Yeah, absolutely. So one of the things that's really important for this concept of that light field master is the ability to not have to go back into visual effects, into any of those post environments, and then re-render different things and different assets. So the concept here is what you're able to do, and what we showed, particularly on that wedding shot that we showed, you're able to render out all those CG elements as a 4D light field. You can do it in several different ways. If you want to do it lightweight and have some of the benefit, you actually render out just the 2D image plus a Z buffer, have some higher resolutions, and then from that content you back project, that's what we call it, in order to get into the light field, and it's completely calibrated to the actual optical system. The other way that you maintain far more benefit is by rendering out a rig of approximately 7 cameras, and that is then giving you the ability to shift perspective and to do a whole bunch of really interesting things, the exact same things that you can do with all the light field content that we just shared. And it's a relatively lightweight process for the CG world, because it doesn't have to be full resolution when you go into that kind of an environment.
So I'd be remiss if I didn't ask someone who's living in the future something about the future, since you clearly have a time machine. I know that Lytro has talked a little bit about VR as well. How do you see this sort of progression going from the Lytro Cinema to VR?
So everything that Lytro does is all about volume. So it's the same core processing engine that is shared between everything that Lytro does. It's the understanding of the XYZ coordinate, or the pixel position in space, that allows you to retain those rays of light and understand how to move with basically 6 degrees of freedom. So what you saw today with Lytro Cinema, it is very specific to address the cinema market as from one field of view, where you have a limited capability for shift but basically the full optical system. For the VR technologies, which is a very different hardware build, it's all about that immersive experience for 360 capture, but you still retain all of the rays of light to give you the capability to freely move within a specified volume.
Well, John, it's been fantastic talking to you. Congratulations on the keynote, and we wish you all the best in the future.
Hey, thank you so much. It's been a pleasure, and thank you for everything that Foundry has done.
It's been a blast. Cheers.